Okay, I'm gonna shoot for video number 3 here on my math series. Welcome back. This will probably be the last one, and then I'll call it a night for the night. Fractions. Okay, we just finished up a video talking about how 5 halves is 2 1/2. Well, like I said, this is an improper fraction, and this is its mixed numeral counterpart. This is the way we talk. When we answer a question, generally speaking, we're going to put it in this form, which you simply divide it and put your remainder over top of the outside number of the division problem. Now, when you're converting back to an improper fraction, which is very rarely going to happen, most of the time in math, 90% of the time, you're going to be converting improper fraction amounts that you get during the course of solving a problem into mixed numerals to state as your answer. Okay, but there is a time in math where you need to take mixed numerals and convert them to improper fractions, and I can tell you that is most often going to occur when you're multiplying and dividing fraction amounts that have a value of more than 1, and we'll talk more about that in a few minutes. We're just talking about what fractions are right now. This is just an introduction to what fractions are, understanding fractions. So 2 1/2 can be converted back to 5 halves by simply multiplying these numbers together and adding this and putting that amount over top of this number. And most often this is memorized by students this strikes a chord in several students I've worked with. Oh yes, I remember this. You multiply this and add this. 2 times 2 is 4 and 1's 5 over 2. And that's correct. But what you're actually doing there, just keep in mind, you have 2 whole items here made up of 2 pieces each. That's what that bottom number tells you, remember. If you have 2 items made up of 2 pieces each, that's why you're multiplying. 2 items made up of 2 pieces each would be 4 pieces. And keep in mind, we're putting it back into its piece form. So those 4 pieces with the additional piece left over that we had added would be a total of 5 pieces out of items it takes 2 pieces to make whole. So there's kind of just an introduction to converting mixed numerals and improper fractions back and forth. So let's kind of recap what we've talked about in fractions. Are that when you have a value of less than 1, it's called a proper fraction. Proper. And improper, which is the same, you can express that value as either improper or mixed, is when you have a value of more than 1. Okay, so let's explore a little more about fractions. Let's talk about them. You can and keep in mind that any mixed numeral has a proper fraction in it, so you have to learn how to deal with these proper fractions. Well, let's write a value here. Let's do a picture. Let's do a birthday cake. Happy birthday to me. And let's say we've eaten half this cake, and obviously we've got this thing cut in 2 pieces. So what did I tell you? The bottom number tells you how many pieces the item is cut into. Better draw some icing here. And how many if this item, we can see it was cut in 2 pieces. We have one of the pieces gone, one of the pieces here. We would obviously put our 1 up here because we have 1/2 the cake. Okay, let me ask you this. After we see that we have 1/2 the cake, what if this cake wasn't cut into 2 pieces? What if it was cut into 4 pieces? How much of that cake do we have now? I'll let you think about that, and I know a lot of you will probably say, well, 2/4. Yeah, and that's very true. It's now cut into 4 pieces, and we have 2 pieces. But do I have any more or less cake than I had when I called it 1/2? No. There's the exact same amount. Hence, you can express proper fraction values with multiple numbers. The same exact value. This has the same exact value on a number line. Let's draw a little number line here. 1/2 would be between the 0 and the 1, directly halfway, between the 0 and the 1. 2/4 is also there. 3/6 is there. Look at this. We can cut this into 8 pieces. We now have 4 out of 8. Well, guess what? That's still half the cake. We still have half the cake. It just depends on, the expression of that value just depends on how many pieces the item's cut in. So you get this concept, and we're going to talk very briefly, some more terminology about the concept of equivalence. E-Q-U-I-V, E-L-A-N-C-E, E-L-E-N-C-E, equivalence. I didn't tell you this was a spelling class. The concept of equivalence. Equivalence meaning equal valued fractions with different digits to express those. So we did it with a picture just now. Now let's see how to explore this numerically. Let's take, well, we won't use 1/2. We've overused that. Let's use 3/5. There we go. 3/5. 3/5. Original item cut in 5 pieces. We have 3 pieces of that. Well, what if we recut that item? What if we didn't cut that item into 5 pieces? What if we cut it into 10 pieces? How many pieces would we have? Keep in mind the birthday cake picture. Well, if we doubled the amount of pieces that the item was cut into, we would be doubling also the amount of pieces that we either have or that are missing. So we would double that, we would double this by multiplying by 2, and we would end up with 6. And we can easily see here that 6/10 and 3/5 represent the exact same value. So, that stated, it's important to know how to do that. Now, why? Why is it important to know how to do that? Well, we'll talk about that in a moment, because the only way, keep in mind, we're going back to our broad arithmetic agenda here, in that we've got to learn how to add, subtract, multiply, and divide whole numbers and parts of numbers. So here we are in our first language of parts of numbers. We're going to very soon have to know how to add, subtract, multiply, and divide these, after we of course explore what a fraction is and all the facets of fractionality, if you will. So what I'm going to do now is I'm going to show you, I could give you some examples of this, but you not only have to go up in digitry, and this is going to be especially handy for adding and subtracting fractions, and I'm sure you've heard of finding common denominators before. It's a big intimidating subject that scares a lot of people, but in order to add and subtract fractions, you have to have denominators that are the same number. The pieces have to be cut in the same size, and I'll illustrate that in the next video with some pictures. But you not only have to know how to do that, but because we as human beings would like to always simplify things as much as we can, you also are going to have to know how to, when you get a fraction value as an answer, you're going to have to know how to reduce the fraction. And I'm sure you've all heard of reduce. Look at me, reduce. Reducing fractions. We're going to have to know how to reduce these. And this opens up, I hate to overuse the phrase can of worms, but this opens up a bucket of pythons, because we get into some more terminology of these things called factors, meaning numbers have components that make them up by means of multiplication. Those are called the numbers factors, F-A-C-T-O-R-S. Factors. Factors are numbers that you multiply together to give you a number, another number. So like, for instance, 1 times 6 would give us 6. These come in pairs, obviously. 2 and 3. 2 times 3 gives us 6. So the idea of reducing a fraction and expressing it with the smallest digits you possibly can would be that you would factor these numbers. And I'm going to show you a much easier way to deal with fractions. Please, for those of you who think, oh, this is just another standard math instructional video, I'm going to show you a much easier way to deal with these. We're going to simplify this, and really, you may as well set fire to all those papers you've been frustrated with that have you factoring and common factor crap, which is important, but I'm going to just show you a little more simple way to look at it. We would then find our biggest common factor, the greatest factor that these two numbers have in common, which in this case is 2. And if you'll remember, we multiplied 3/5 by 2 and 2 to get 6/10. So it's a no-brainer that 2 is our greatest common factor. And when we divide 2 into 6, we end up back with 3. We divide 2 into 10, we end up back with 5. So 3/5 is the smallest way that you can express the value 6/10. And I'm out of time once again. I can't believe how fast these 10-minute clips go. And the next video segment we'll dive into is I'm going to give you just a number lesson on factors so that we can easily learn how to reduce these fractions, and that is a hump that you can easily overcome, and then we'll spiral into some other stuff. Join us on video 4.